Okay, here are the 6.6 notes, page 1. We're talking about exponential and logarithmic equations. So there are a couple of things to look for. Anytime we have a variable in the exponent, we've got an exponential equation. If the variable's the base, it's not exponential, it's a power function. So we are looking for where we have variables in the exponent. Okay? Sometimes we can make this pretty straightforward. If our bases are the same, we can use the base exponent property and just compare the exponents, which makes sense. Sometimes it doesn't look like the bases are the same, so we have got to take care of that ourselves. So take a look at A. We've got 2 to the 3x minus 7 equals 32. If we can make those bases the same, we're going to be okay. 32 is 2 to the 5th. So I've managed to write these with the same base. So all I need to do now is solve for the unknown in the exponent. Let's see if I can make this just a little bit smaller. That means that 3x minus 7 equals 5. Add 7 to both sides, and 3x equals 12. Divide both sides by 3, and x equals 4. We can always plug into double check. 3 times 4 is 12. 12 minus 7 is 5. That works. B has got an extra step to get there. We know that 27 can be written base 3. So I'm going to write this as 3 to the 3rd to the 2nd equals 3 to the 2x minus 5. We know that when we raise a power to a power, we multiply those. So that's 3 to the 6th equals 3 to the 2x minus 5. We're going to carry that over here. 6 equals 2x minus 5. Add 5 to both sides. And x equals 11 over 2. Some of these, like on the left, we could kind of guess and check. The right, probably not as easy to do. Okay. Sometimes both sides of the equation cannot be written with the same base. In that case, we are going to take the same log of both sides to see if we can get that variable out of the exponent. Once we do that, then we can just compare the arguments. Okay. So take a look at A. I've got a base 3. I've got 3 to the x, so base 3 that I need to get rid of. So what I'm going to do is go ahead and log base 3 both sides. Log base 3 of 20 is just a number. It's a little ugly, but it's a number. On the left-hand side, we can use that power rule. I'm going to pull the x out front. We're going to slide up here. Log base 3 of 3. We know this is just 1, right? 3 to the what power equals 3? So I got x equals log base 3 of 20. I can plug that into a calculator or use change of base, depending on what kind of calculator you're using. And I get 2.7268. Okay. B, we're solving. I'm going to start by dividing both sides by 100. I want that e by itself. So I got e to the 0.08t equals 25. To get rid of the e, I'm going to use log base e, so natural log. Oops, natural log of 25. Power rule again. I got 0.08t times the natural log of e, which we know is going to be 1, equals the natural log of 25. That gives me a 0.08t equals natural log of 25, and t equals the natural log of 25 divided by 0.08, which gives me 40.2359. I know, super exciting, isn't it? Okay. C, because we don't have the same base on both sides, but we do have variables in the exponent on both sides, we are going to start, now let's see, we could go log base 3 on both sides or log base 4. Let's go log base 4. I'm going to go log base 4 of 4 to the x plus 3 equals log base 4 of 3 to the negative x. Now, I know that this part here is going to equal 1. Sorry, not the x, but I'm going to pull that x plus 3 out front first. We're not going to get sloppy, log base 4 of 4. And I can also pull this negative x out front here, log base 4 of 3. And log base 4 of 3, even though it's kind of ugly, is still a number. Okay, so this goes away. I get x plus 3 equals negative x times log base 4 of 3. We need to get all of those x's together. So I am going to go ahead and move, let's see, how do we want to do this? Let's try to keep x's positive. So I'm going to take this whole term and move it to the other side by adding to both sides. So I get x plus x times log base 4 of 3. And I'm going to go ahead and move that plus 3 over. I got a minus 3 here. Now I can factor x out of both parts. And then divide. And when I crank through the numbers for that, we get a, what do we get? Let's see, negative 3 divided by 1 plus log base 4 of 3. I got a negative 1.6737. And there's page 1.